So besides knowing what an ionic bond is and how they're formed and how to write a formula unit, you're expected to know some of the other properties of ionic compounds. So one property is that they are crystalline solids. That means there's a regular repeating arrangement of ions in the solid. And these ions are strongly bonded together by the opposite charges that are formed when the electrons are gained or lost. The structure is very rigid and they're always solid at room temperature. So here's the structure for sodium chloride. So it's kind of like this cube-like shape. So each sodium, which is orange in this picture, is surrounded on actually 6 sides by chlorine all the way around. So when we're talking about a formula unit, when we just say NaCl, it just means that there's a ratio of 1 sodium for every 1 chlorine. So each sodium is surrounded by 6 chlorines, but each chlorine is surrounded by 6 sodiums. So in the lowest ratio, that's still 1 to 1. But you can see in this picture that the actual molecule, the compound itself, is really large, this network of bonding that happens. Here's a picture of table salt under the microscope, and you can see that the little cube-like shapes that comes from the bonding, the ionic bonding of these ions here. Another property is that they have extremely high melting points, and this can be estimated by what's called the coordination number. This is the number of ions of opposite charge that surround it. So here's table salt again. It doesn't matter which one we consider the purple to be. Let's say it's sodium. It's surrounded by 1, 2, 3, 4, 5, 6 chlorines on each side. You could do the same thing for chlorine. Each chlorine is surrounded by 6 sodiums on each side. So the coordination number for table salt would be 6. Different ions can have different coordination numbers. It depends on the ratio of the atoms in those formula units. But the higher the coordination number, the higher the melting point of that compound. A third property of ionic compounds is their conductivity. Now, conductivity means electricity can move through them. In a solid, the ions are locked in place. So solid ionic compounds are not conductive. So the ionic solids are considered insulators. But when they're melted, ions can move around and they do become conductive. So here's an example. So in this little diagram here, we have a little light bulb with these little prongs, and they're connected in this container of solid, rigid, crystalline ionic structures. You can see the light bulb's not lit up. All of the electrons are locked securely in place, particularly on the non-metal of this formula unit. But if we melt it, the ions start to move, and they can move from one prong to the other and conduct the charge, and the light bulb will light up. Here's another example. So ionic a little fast. So aqueous ionic substances can also conduct. So because salts have an extremely high melting point, it's hard to achieve the temperatures that you would need to have molten salt. Table salt, for example, won't melt till something around 800 degrees Celsius, which is really high. But you can get the same effect by putting these ionic substances in an aqueous or a water environment. So you can see our voltmeter is reading 0 here, and we have a power source connected to it, but the charge can't carry from one electrode to the other. I have salt in this container, but the salt is solid and it's not touching. And even if it was touching these prongs, it wouldn't conduct. But if we add water to this mix, now it will dissolve the bonds, it will break the bonds, and the ions will disassociate or come apart. And we can see the voltmeter is now reading, because as these electrons and these ions move from one side to the other, it can conduct the charge and light up the light bulb, or you get a reading on the voltmeter. So in summary here, ionic substances are crystalline solids. That means they're a regular repeating shape, and they're solid, so they're always solid state of matter unless you have really, really high temperatures. So they have high melting points. And ionic substances can conduct electricity, but only when they're melted or dissolved in water. If they're not, they don't conduct electricity.